Okay, so welcome, and today we're going to talk about another method of solving a system of equations called the elimination method, or some textbooks call it the addition method, and you'll see why. So in this case, it's another method, just like the substitution method. They both will work in every single case. It's just that in some cases it's easier to apply one, or more efficient, if you will, because of the way it's set up. Like, for example, in this case here, this is set up so that each equation is in what we call standard form. And since both of these equations are in standard form, the way we would have to use, in order to use the substitution method, we would have to solve one of these two equations for one of the variables, right? Either x or y. Well, since it's already in this form, instead of taking the extra step and solving for one of the variables and using the substitution method, well, what we could do is, if you notice that we have these two variables, coefficients, right, are the same. These two terms are the same except opposite signs. So what happens is, if we add these two equations, the variable will drop out. So if we add these two, we get 6x. 3y minus 3y gives us 0. And then 7 plus 5 is 12. And so what we end up with is 6x equals 12. And so the y variable has been effectively eliminated. Okay? So now all I have to do is solve for x. So if I divide both sides by 6, I get x is equal to 2, and now I can do what's called back substitution, right? So I can now, either one of these equations, it does not matter which one, I just have to plug x back in and then solve for y. So if I use this one, I'll get 2 times 2 plus 3y equals 7. So that's 4 plus 3y equals 7. So I subtract 4 from both sides, right? And then I get 3y equals 3. And then I divide both sides by 3, right? And 3 divided by 3 is 1. So I get y equals 1. And now I've got my answer. So my answer is the ordered pair 2, 1. And that's the solution to the system of equations. And of course, what do? Make sure you check your answer. Plug 2 and 1 back into both of these equations and make sure that you get a true statement for both of them, right? Because that's what it means to be a solution of the system, right? Okay. Have a great day.